Hi everyone, in this video we are going to discuss about how to factor an algebraic expression which is of the form a cubed plus b cubed, which is essentially like a sum of two cubes, right? Each of the terms are in the form of cubes. So this is a sum of two cubes and we are going to now try and find out if this type of an expression can be factored. Now can we assume this expression to be a function of a? Sure we can, there is no problem. So we can simply assume that this is equal to f of a. Let's just assume that this is equal to f of a, right? And now think about it. If we use negative b in place of a, so what I'm going to use? I'm going to use negative b in place of a, right? And then what happens? If you look at it, so we can say f of negative b will be equal to negative b whole cubed plus b cubed. And all I have done is I have substituted a with a negative b, right? And from here what do we get? Well, from here we see that negative b whole cubed would be negative of b cubed plus we have the positive b cubed. So from here we get 0. So we are saying that when we substitute a with a negative b, we get 0, and we can say this is going to be the remainder if the original expression is divided by a plus b. So if we divide the original expression by a plus b, then the remainder is becoming 0. This is the remainder and the remainder is actually now 0. So what does that mean? That clearly means that if the original expression, which is a cubed plus b cubed, is divided by a plus b, the remainder will be 0. That means we will get a quotient which will be the other factor. So if we multiply this divisor, which is a plus b, by the quotient, then the product of the divisor and the quotient will give us the original expression because there is no remainder, right? I have already created a detailed video on remainder theorem. Feel free to watch it, and in fact I have another video also on the factor theorem. So feel free to watch both of them. I will provide the link in the description, and from there you will know how to calculate remainder when a function or an expression is divided by a certain expression, right? So from here we now need to find out if we divide a cubed plus b cubed by a plus b, what would be the quotient, right? So I'm going to do a simple division. So the first term of the quotient would be a squared because a would go a squared times into a cubed, and b times a squared, that would be a squared b. And then let's change the sign. Then we'll do the algebraic sum. So a cubed terms will cancel each other and we are going to be left with a negative a squared b and plus b cubed. And the next term in the quotient would be negative ab, because when you multiply negative ab with a, that is going to give us negative a squared b. So now this will be negative a squared b, and then negative ab times b, that would be negative ab squared. So here again let's change the sign and let's do the algebraic sum. This is going to cancel out each other and we are going to be left with positive ab squared and positive b cubed. And then as you can see, to get ab squared we need to multiply a by a b squared. So the next term in the quotient would be a positive b squared. So we get ab squared and plus b times b squared, that would be b cubed. And now looks like we are at the end of the division because these terms will cancel each other. Here again they will cancel each other. So we are going to be left with nothing in the remainder, right? So our division is completed and we see that there is no remainder, and the quotient of this division is actually like this. That's the quotient of the division, which is a squared minus ab plus b squared. So then from here what do we see? Well, we see that if a cubed plus b cubed is divided by a plus b, then we are going to get a quotient of a squared minus ab plus b squared. That means if we multiply a squared minus ab plus b squared by a plus b, that's going to give us our original expression, which is the a cubed plus b cubed. So we can write our original expression as the product of a plus b times a squared minus ab plus b squared, and that is the factored form of the original expression, which is a cubed plus b cubed. So whenever you have an algebraic expression of this form, which is like sum of two cubes, we can factor it into two factors like this, like a plus b and a squared minus ab plus b squared. So let's take an example. Suppose we have an expression like this, 8 times x cubed plus 1. For factoring, the first thing we should always do is first we should check and see if there are any common factors between the terms, right? Now in this case we have two terms and obviously there is no common factor. So then do they look like difference of two squares? No, they don't. But do they look like sum of cubes? Yes, they kind of look like sum of cubes. We are not quite sure, but it can be expressed in the form of sum of two cubes, right? So let's give it a try. So from here, can we say that 8x cubed would be a cube of 2 times x, so we can write it as 2 times x whole cubed. that will give us 8x cubed, and then plus 1, well 1 no matter what power you raise it to, it is always 1, so can we write 1 as 1 cube? So now you easily see that we have a form which is like sum of two cubes, and if we simply assume this to be a and this to be b, so this is like a cubed plus b cubed, so then we can easily factor them. Well, what would be the factors then? Well, from here we'll say okay, then the first factor would be a plus b. So what is our a? Well, our a is actually 2 times x, that is our a, and what is the b? B is 1, so that is a plus b times we have a squared. Now for a squared, can we write it as 2x whole squared? This is our a squared minus ab, so minus a b, a is 2 times x, and then plus b squared which is 1 squared, that is our second factor. So from here we can say okay, this must be equal to 2 times x plus 1 times 2x whole squared, that would be 4 times x squared, and then minus 2x times 1, that would be 2 times x, and then plus 1 squared which is 1. And that is the factored form of our original expression, which is 8 times x cubed plus 1. I hope it all made sense so far. Let's take another example. Let's suppose we have an expression like this, 8 plus 27b cubed, right? So then again, do we have any common factors? We don't. So does it look like difference of squares? No. Does it look like sum of cubes? Yes, almost. Let's try to see if we can express it into the form of sum of two cubes. So 8 can be written as 2 cubed, and then 27b cubed can be written as 3 times b whole cubed, because if you think about it, that's going to give us 27b cubed. And now clearly you can see that this is now looking like sum of two cubes, where a is actually 2. If we assume that this is a cubed, meaning a being 2, plus then 3 times b, if we assume that 3 times b is actually b, so this is like a cubed plus b cubed. So now this can be easily converted into the factor form. So the factors would be like this, it would be a plus b, so this is a plus b, and then times it would be a squared minus ab plus b squared, and that will be equal to, what is a in this case? A is actually 2, so this should be 2 plus b is actually 3 times b, so that is 2 plus 3 times b, and then a squared, a is 2 minus ab, so a is 2 and b is 3 times b, and then plus b squared which is 3 times b whole square. Right? And if we simplify that, this is going to look like this. It would be 2 plus 3 times b, and then times it would be 4, 2 squared would be 4 minus 6 times b, and then plus 9b squared. And also you can write it like this. You can say okay, if we want to write the terms with the algebraic variable first, so you can say okay, this is then 3 times b plus 2, and then times 9 times b squared minus 6 times b plus 4, and that is the factor form. So the original expression that we took, 8 plus 27b cubed, that can be expressed in the factored form like this, 3 times b plus 2 multiplied by 9 times b squared minus 6 times b plus 4, and those are the two factors. Let's take one more example. Let's suppose we have an algebraic expression like this and we have to factor it. So the first thing we want to do is we want to check and see if there are any common factors between the terms. In this case, there are no common factors. So then what should we do? Well, let's first try to separate it into two terms, right? It looks like a rational expression. So let's try to separate it into two terms. So the first term would be a to the power 6 divided by a cubed and plus 1 over a cubed. And from here what do we get? Well, a to the power 6 over a cubed, that will give us a cubed, and then plus 1 over a cubed, and this can be written as a cubed plus 1 over a whole cubed. And now you can clearly see that this is looking like sum of two cubes. So if we simply assume that this is our a and this is our b, this is looking like a cubed plus b cubed. So then this can be factored into a plus b times a squared minus ab plus b squared. So this is going to be a plus b times a squared minus ab plus b squared. Now what is a in this case? Well, a is actually a, and what is b? B is actually 1 over a, and then a squared, so that would be a squared minus a times b, that would be a times 1 over a, and then times 1 over a whole squared. So from here what do we get? Well, from here we get a plus 1 over a times we have a squared minus this a right here and this a, they will cancel out each other because one is in the numerator, one in the denominator. So that will give us a 1 right there, and then plus 1 over a squared, because 1 squared is actually 1. So I could have written it like this 1 squared, but 1 squared is actually 1. So that is why I wrote it like that. And then if we rearrange little bit, we can write it like this: a plus 1 over a times a squared plus 1 over a squared minus 1. And that is the factor form of our original expression. I hope everything made sense so far. Thank you for watching. See you in the next video.